So, you clicked on the video and you're probably wondering, what is gravity? Well, gravity is what's keeping us here on the surface of the planet. It's what brings the moon around in the sky every night, and it's what circles our planet around the sun. At its essence, gravity is the attraction towards a body of mass that is created by that body of mass. For example, let's say we have a mass creating a gravitational field around it. Objects inside that field will accelerate to and be attracted towards the mass creating that field. Now let's say we have a second object further out. Well, it will also be accelerated towards the mass creating the field. The only difference is that the two objects are a different distance away from that mass. So in order to find the actual quantitative acceleration of the objects in the field, all we need is three things. 1. The mass of the body that is creating the gravitational field. 2. The distance the objects are from the center of mass of that body. And 3. The gravitational constant, big G. Please see the description for a little bit more on big G. Once we have that, we're going to plug them into our formula. The acceleration of gravity is equal to the mass of the object creating the gravitational field divided by the distance the object is from that mass squared times big G. Now we see that the two objects inside the gravitational field are at different distances and therefore have different accelerations. However, let's say that the two objects were the same exact distance away from the mass. Well, that means that they would both have the same exact acceleration towards it. To solidify this concept, let's use a real-world example. Now the Earth has a giant mass, which creates a gravitational field around it, which emanates from the center of the Earth at the core. Now this heavy bowling ball and this light lemming are both just above the surface of the Earth, the same distance away from the center of the Earth. That means that they're both going to accelerate towards the center of the Earth at the same exact rate. Now that we've seen the acceleration of the Earth's gravity in action, let's calculate what it is. The first thing we need is to know that the mass of the Earth is 5.972 times 10 to the 24th kilograms. We also know that the bowling ball and the apple are on the surface of the Earth, and the distance from the center of mass from the Earth to the surface is actually the radius of the Earth, which is 6378.1 kilometers. Plug in this into our equation for the acceleration of gravity, that the mass of the Earth divided by the radius of the Earth squared times big G gives us 9.8 meters per second. So that means any object relatively close to the surface of the Earth will accelerate towards the center of the Earth at the same exact accelerational rate of 9.8 meters per second squared. Well, there you have it. I hope you enjoyed learning just a little bit about what gravity is, as we talked about the acceleration of gravity. Stay tuned for part 2 of our series when we learn about the force of gravity.